Thanks for inviting me. Happy to be here.
All right, thank you, Matt. Welcome. This is our April meeting, and we plan to move relatively quickly through our business meeting today so that we can get right to Alison's presentation, which we're all very excited about. So welcome. Let's first approve the minutes. Is there a motion to approve?
So moved.
So moved.
Okay, is there a second? Thank you. For the financial report, last month we had a total of $1,851.79. We are looking at approximately $160 in credits from memberships and approximately $156 in debts, leaving us around $1,855 for April. There was no correspondence for me to relay. We do have a bit of unfinished business to tackle, and that is our ongoing budget discussion. And at the last meeting, we were talking through the budget items, and there was a request for more information about the cost for Whereby, which is our host for our online meetings. And so it's become very important for us over the pandemic as we're able to hold meetings. And there was a request to find out if there were other options available that might better suit our needs as a society. And so Matt took the initiative, and he actually did a lot of work in looking into the differences between Whereby and Zoom and other options. And I'm going to let him tell us what he found out about that.
Yes.
Yes.
Oh, and that's my fault. I apologize. I didn't correct that from last time.
Well, Zoom is not as reliable as this. I've been to a lot of Zoom meetings, and this whereby is very steady. I'm not for Zoom, so that's my 2 cents worth.
Mhm.
But Zoom would not allow us to do the star party online, would it not?
I'm pretty sure it does allow that because the Raleigh Astronomy Club uses Zoom. If you want, I'll reach out to them and find out what challenges they've had with Zoom and whether or not they'd recommend it.
Okay.
Can I ask a question, Matt? Is there a difference on our end as far as like the star parties, as far as ease for all the individual users putting into the room using Zoom as opposed to this?
You know, Matt, Selena's been having, of course, since all of their classes have been virtual, she's had 2 classes on Zoom. It is reliable. It sounds like to me the biggest thing would probably just be the saving of $240 cost a year, and like you said, finding someone to learn it. But it's extremely reliable.
Mhm.
And I vote we stay where we are. I say I vote we stay where we are. Then I'm interested in putting a 12-inch telescope online.
What does all this look like once we're able to meet in person again? Are we going to continue to stream this? Are we trying to fix a short-term problem with a long-term solution, or is this something we're going to be doing regardless if we're meeting in person? We're going to be streaming and allowing people to join remotely.
Yeah. Well, Matt, I think it's, oh, go ahead.
Yeah.
I'm pretty sure that they're offline edited because the weekend training stuff that I attend via their Zoom meetings in the Raleigh Astronomy Club, they publish the videos later after it's done. So I'm sure it's probably what you're saying. It's probably saved locally and then edited if they need to.
Well, Matt, I think it's a good plan to pull all that together for the newsletter and for us to actually have a result, a final discussion and a decision next meeting. So thank you very much for putting the work into looking into this. Okay, moving on to some new business. I'm going to bring it back to Matt again, who is the chairperson of our committee for officer nominations. As you should know, we are electing a new slate of officers next month. Mm-hmm.
Yes.
Yes.
We can hear you just fine though.
Fantastic. Yes. Thank you very much, Matt, and to the committee. Thank you all. And that, I think, is a nice segue into this last bit of business, kind of more of an announcement. In the newsletter for this month, I used my little blurb to discuss ways that you can be aware of what's happening in the club. And of course, through keeping your email active and up to date, checking out our Facebook, which is also very active. And specifically, if you're interested in things like imaging, buying a new telescope, have questions about something you own or are looking to get, just want to do a general chat with the club, or have any sort of communication in that realm, I encourage you to join our groups.io. And that's just Google groups.io. And it is, I think, if you search Barnard Astronomical Society through the groups.io, you'll see that there are a number of listservs for member chat, social chat, the imaging discussion, which also posts the nights at Cloudland Canyon when that group goes up there, and also our 100-year anniversary organizing group. So I encourage you to join those so that you can stay active in communication with the club.
If you want, I can go ahead and if you get me the club email list again, I can send out another round of invites to the email list from the groups.io.
Okay. Who was that was speaking? Oh, okay. Okay. Fantastic. Thank you. Okay, so
and just on that note, though, for those of you on the call, it will come from like a generic groups.io account, so you might have to check your spam folder over the next couple of days just in case it gets kind of put in the wayside. But it'll be I'd send it to the members general membership chat group, and you can opt into the others unless you want me to do all the groups. I don't think that's appropriate unless you want it.
So you can use the newsletter email addresses I sent to you.
Okay, yeah, that'd be fine. If that's the current list, I can just copy and paste those in, and you should be able to get those invites out. So
great, thank you.
We're doing pretty good.
Okay, so final announcements. Don't forget next meeting, we will have elections, but importantly, we're going to move the start of our business meeting to 6:30 so that our program will begin at 7. This will allow us to put the program as the focus of our live stream. And for those who want to attend the business meeting, we can reserve it for the time between 6:30 and 7. If you have any future program ideas, please contact Ralph and let him know. And if you have any leads on someone who might be interested in presenting to our club, please do that. Also, if you would like to contribute to the newsletter, so if you're capturing some great images, have a product review, please send those to Bobby Thompson. Are there any other announcements?
Oh, they can send for sale articles too.
Okay, for sale. Fantastic.
I'm just
Thank
so
you.
proud to be here.
We're glad you're here, Bobby. Okay, so with that, we will move to the adjournment portion of our meeting. Do we have a motion to adjourn?
I so move.
Thank you.
Second.
Fantastic. We do not need a second for that. I've learned. Okay, great. So we are now moving to a very exciting portion of our program tonight, and that is our program given by Alison Pryor. And I will just let Alison take it away. Let me get off my screen here. And thank you, Alison, for joining us. We're looking forward to this.
Yeah, thanks y'all for having me. Just to give y'all a heads up, I'm working off my laptop, and so I don't have a second screen. So once I share my PowerPoint, I won't be able to see it if y'all raise your hands if you have any questions. So if Matt or Amy or someone else, if there's questions in the middle, can kind of facilitate, and you can break in and interrupt me, or I can wait till the end and answer all of them. So just wanted to throw that out there. If you raise your hand, I won't be able to see it. So, all right, let's get the screen share started.
Please, can you cut your cameras and your microphones?
All right, so for the presentation, we'll be going over weather conditions that you're going to want to be looking for good astronomical observing. And the kind of the presentation plan for the day today is I'll talk about some key weather facets. You know, there's a lot of variables and ingredients that go into weather, and you're talking about an atmosphere that is a three-dimensional space that we're looking at. So I'm going to kind of hone in on a few key ones that I think will be handy for you as you're planning to maybe view the night of or planning out a week in advance. Typically, when we're talking about weather, you really only want to look about 7 days in advance, maybe 7 to 10, but things can change a lot even within that 7-day time frame. And how those key things to look at are going to help or potentially hurt your observations. And then we're going to go over a real world situation. I made this PowerPoint last Thursday, so I have a kind of a case example for Thursday night through Friday and Saturday night of this past weekend when we had clear skies, and hopefully y'all got some viewing in and kind of tell me how it ended up working out for you. And then review some online resources that are available to you. So these are going to be ones that are weather focused. All the ones that I'm going to show you are free and open, so you can easily go to them at any point in time. And again, use them for night of, but also planning out for in the future. So kind of main thing that we're talking about is when you're dealing with meteorology and weather, there are three main ingredients, and they're going to be simple ingredients. So number one, temperature. That's going to be the most basic and something that you certainly can understand even beginning as a young child, because it's going to affect how you feel, like on your skin, feeling that temperature. But it also is going to make a difference in the way that particles in the air are going to be moving around, and you're going to get convection from that. And so I think that everybody's heard about warm air rising. So we have the sun during the daytime coming down to the surface, heating up the surface of the earth. You get that warmer air and it begins to rise, and you get convection currents that develop. So there is some turbulence in the atmosphere that's fueled by temperature. Number two is moisture. And there's a lot of different ways that we measure moisture and look at moisture in the atmosphere. And of course, you can think of straight off precipitation, whether that's rain, snow, sleet, whatever it may be. But of course, moisture is also in the form of clouds, in water vapor that you can't see, in fog at the low levels, basically just whatever your humidity is. And not so much for you for your astronomical viewing, but when we're talking about weather, the water cycle is really important in what phase that it's in that evaporation process. And then third up, I think most people can easily know about temperature and moisture, but the third one, which is really important, is talking about pressure. And this is certainly going to come into play when you're making your plans for the future. Is this going to be a good day to look at the sky? Pressure is going to make a big difference. So that's really going to be determining how air flows, which is creating wind. And so when you're looking at pressure, it's always going to go from high pressure to low pressure. So you're going to have that dense combination of molecules creating that high pressure. and they're not going to want to stay in that way. They're going to move to wherever you have low pressure. And that's going to be your horizontal dense combination of now anywhere that you're looking vertically in the atmosphere, you always have higher pressure at the surface, and pressure decreases with height, no matter where you are, no matter what that geography is. But that will all come into play when you're looking at the vertical levels, and then that movement horizontally together with some frontal systems, and we're going to get to that. But when you look at a weather map or you listen to weather forecasts, a high pressure is going to be kind of the same as a ridge. A lot of times we'll talk about ridges when they're higher up in the atmosphere, and then the high pressure at the surface. And then your same equivalent is going to be a low pressure equals a trough. So just very basically, warm air, it's going to rise. Warm air is also less dense, and you get lower pressure. Cold air is going to sink, it's more dense, and you have higher pressure. And so off the top of your head, if you're thinking about sinking air, this becomes more stable. You have warm air rising, remember you have that convection and that movement, that's going to create more turbulence. So that can already get your mind kind of spinning with, hey, maybe those are some different weather conditions that I need to look out for. So here's just a very simple animation to show you this. For low pressure, air is going to be moving towards the low pressure at the surface, and then it rises. As it rises, it cools, the water vapor condenses, and of course you get clouds. Anytime that you have clouds, clearly that's going to be impacting your viewing. But even if there aren't clouds with the low pressure, because of that rising air and that movement, it will degrade your viewing of the sky. High pressure, though, that's what you're going to want to look for. So air is moving away from that surface high. And then above it in the atmosphere, more molecules are going to be sinking down. So as you have air coming down and out, you end up having clear skies. Without any air rising up, there's no force that's going to create any kind of cloud cover. So during the daytime, you have clear skies and sunshine. During nighttime, you're going to be able to see the stars and the moon and the planets and everything that you want to look for. So very basically, high pressure, when you're looking at a weather map, that's what you want to see. Low pressure, that's going to generally indicate worse conditions for your viewing. Whether there's clouds and rain or not, that low pressure is creating a more dynamic atmosphere that will cause some issues for you. So I know that there's kind of two key main factors that y'all talk about for viewing, and thanks to Ralph for pointing these out to me. So the first one, that transparency. So having your clarity of sky, how clear is it? And there are some, moisture, which has been one of the things I was talking about, this weather ingredient, is really key in transparency. But you can also talk about smoke, particulates. This time of year, pollen can cause an issue in the springtime. So moisture, smoke, particulates all can work to reduce transparency. They scatter light, you're losing that detail and that contrast of objects. So basically, you want to find a time when there's less moisture, when you're talking about those weather elements, and that's going to give you that better transparency. Well, now seeing, it's a measure of atmospheric turbulence. How stable is the sky? So if you have wind, if you have that convection that I was talking about, that low pressure or fronts, and we're going to get to those fronts, or even geography. I'm not going to dive into geography as much. We have to deal with it a lot in our weather forecasting, especially for our area with snow, but I know a lot of times y'all are kind of avoiding that by going up to some of those mountaintops for viewing. But that's all going to come into play of what atmospheric turbulence is based on the movement within there. So more turbulence, you're going to get bending of light, those objects will twinkle, and poor seeing. So if you have greater wind, if you have that low pressure in the area, even if it is a clear sky, you can still have lower seeing conditions without having clouds that are in the sky. So let's first just kind of compare our temperature and moisture combinations. So we'll just set pressure by the side for a second. Again, basic idea. The warmer the air temperature is, the more potential to have higher amounts of water vapor in the air. So on a hot summer day, you automatically can have more water vapor in the air than a cold winter one. It's going to have that potential to have higher humidity. And there's really two ways that you can report moisture. A lot of times in meteorology, we do this first way, which is dew point, because it's a direct measure of the amount of moisture in the air. It's going to tell you the temperature at which air needs to be cooled to reach saturation. So that means if air is rising and it cools and it hits that dew point, it'll condense out and make clouds. If you have a cold cup of ice water or Coke in the summertime and you get dew on the outside of that glass, that's because it's hitting that dew point. You get saturation and it condenses out. Fog is another example of that. So a dew point is a really great way to know what the moisture is. And if you're just looking at a general weather forecast, if a dew point is in the 20s or the 30s, you know you have very dry air. So that means there's not a lot of moisture. Your transparency is going to be good. If it's in the 40s, then that's still going to be dry. 50s is kind of what we call comfortable humidity. It's kind of middle of the road. 60s, that's going to be getting more humid. So you'll begin to probably have a little bit of transparency issues. Issues with that humidity. 70s, that's going to be very muggy. So even if you have no clouds in the sky and a dew point in the 70s, that will be a little bit problematic. For relative humidity, that's going to be the second way that you can measure and track the moisture that's in the air. And it's based off of a given temperature. So relative humidity is the percentage of saturation at a given temperature. Comparatively, if you have 40-degree temperature at a 90% relative humidity, that will have less moisture in the atmosphere than the 80-degree temperature at 90% relative humidity. So because of that dependence on the temperature, that's why we typically look at dew point, but certainly you can use whichever factor you want when you're viewing forecasts for the weather and you're kind of focusing on that moisture component. But the takeaway from this is that your ideal viewing is that you want that low humidity through all levels of your atmosphere. So your low, mid, and upper levels of your atmosphere, which means you're going to have that less water vapor. Cooler air is going to be able to have less water vapor anyway, so you're more likely to have that lower humidity, which is going to give you better transparency. That warmer air plus higher humidity will give you lower transparency. So your takeaway is that cold nights in the winter or even cool nights in the spring and fall will have better transparency. Most of the summer, our nights really remain humid here. So even if we have a clear sky, it's probably not going to have as good transparency as what you can have during the winter time, simply because of that humidity factor, because there is more water vapor in the air across the area. A lot of times our dew points will stay in the 60s, even in the nighttime during July and August. And kind of one other tidbit to add to this, because we're not just talking about, you know, the water vapor and moisture in the air, but we mentioned moisture, precipitation. This is a good element, that recent rain will knock out pollen and other pollutants from the air, and that will improve transparency. So for us this time of year, for those like few weeks in April when we're kicking out 2,000, 3,000, 4,000 for those pollen counts, having that rain is going to help clear that out and then give you that better viewing and transparency afterwards. So now we're going to work and combine all three elements. So we're going to talk about the temperature, moisture, and the pressure in the form of frontal systems. We like to call them a little bit fancier sounding mid-latitude cyclones. So remember, kind of one that's the more active is the low pressure. High pressure is going to give you stable conditions, low pressure, that rising air, and that's what we have for mid-latitude cyclones. So on a weather map, the blue here with the points indicates a cold front. The red is a warm front. And then we have our low right here. These lines that are circling around here, those are going to be your isobars, which means those are your same pressure lines. And for a low pressure, remember, they circle around, going counterclockwise, and they're going into the low pressure because it's then going to be rising up. So with that, when you look at this area, you have one area down here. I'm going to kind of go to this three-dimensional box, where we call that the warm sector. So there you're going to have warm air and it will be moist. Above this, on the north side of the warm front and on the back side of that cold front, that's where you're going to have cooler, drier air driving down, especially on that back side of the cold front. So when we're looking at frontal systems. Remember, the atmosphere is three-dimensional, so we have to go one area down here. There's multiple levels that we'll look at as meteorologists, but I'm going to kind of just pinpoint a couple for you. This is our 500 millibar chart. So this is our mid-level look at the atmosphere. And what you're looking at is these black lines through here are what we call our isobars. So this is looking at our height lines, our geopotential height lines for this 500 millibar pressure. And the blue arrows here, these are going to be our flags and wind barbs showing you how much wind. And here's our dip. This is going to be a trough, so an area of low pressure. Over here where it's kind of climbing up, this is what we're going to call our ridge line. So we have our low and we have our ridge. So we're already kind of going to be looking over here in this region where that trough is to be the most active area. So now I'm going to show you a surface chart. So here's the surface chart. And you'll notice right here, there's an L, a red L. So there's the low pressure at the surface. I'm going to come back to the 500 millibar, but you notice this biggest dip is a little bit further to the west. And that is very typical. So there's always going to be a little bit of a lag, a difference between where a surface low is and then the upper elevation low is on a weather map. So your surface low is going to be leading it and ahead of it, and usually to the northeast of where that biggest dip is. But what you can take away is really from here all the way down back through here where we have that biggest dip in the upper air is all going to still be pretty active. You have to go further to the west. You can see this H here in Iowa. There's an H here and another one right here for Colorado. Those are where our high pressures are. That's where you're going to get that more stable air, sinking, and clearer skies. So whether you're going to look at a surface chart or look at something higher up in the atmosphere, identifying that low at the surface or the trough higher up is going to tell you just in general where conditions aren't going to be as great for viewing. But once you get a little bit further to the west, you're going to have better viewing conditions. So here's just a little bit of animation to put all of that together. There we go. So we're going to talk about that warm front first. So you have the cool air ahead of the warm front. Then you have warm, moist air that's behind it. Remember, this is usually one that's going to lie from west to east across the area. And that cool air is denser. So the warm air is gently going to slide up above that cooler air. As it rises, it cools, condenses, you get clouds. And then, of course, from those clouds, you can get precipitation, whether that's going to be rain. If it's in the wintertime, it's cold enough, you can get that wintry mix and snowfall across the area. So the problem for you for viewing is if you're on the north side of that warm front, it's not going to be great for going out at nighttime and looking. But even on the south side of the warm front, you still have warm, moist air, which can be problematic for you. Now let's slate it back and we're going to talk about the backside with that cold front as well. So you got the warm, moist air, southerly winds behind it. We have that cold, drier air and northerly wind behind the cold front. The cold front, because that cold air is so dense, it can undercut the warm air and move a lot quicker than a warm front does. So instead of having a gentle slope rising up where you have large spans of cloud and rain, what ends up happening ahead of a cold front is you get a really steep slope. So that warm air shoots up really quickly, that warm, moist air. For us locally, we get all that moisture from the Gulf of Mexico, and that creates more instability. So not only do you end up with clouds, but these are the occasions where you get those cumulonimbus clouds. You're going to get those thunderstorms that are developing right along that cold front, and a squall line may form. So again, warm front area can be hit and miss right along that cold front. When you're seeing the forecast that's moving across your region, you know that's not going to be good viewing. And then on that back side, you're going to have cold, dry air, and those clouds will be clearing out. So looking for a passage of a cold front is always going to be a good indicator to you. You'll have nicer viewing conditions. Here's kind of a combined setup. So I have both that mid layer, the 500 millibar, and some surface analysis on this map. So where you're looking at the red, that's your warm front, there's your surface low, and here is the cold front of the surface. The colors on here are going to be that mid-levels. So I have it labeled as upper on here, but technically it's the mid-level. But the blue, that's going to be that trough. So you can see this line right through here and that little bit of a lag between the two. There's your surface high, more orange further off to the west, that little bit of a difference between that surface and upper ridge. And then here is another upper ridge to this area. I'm actually going to play this because it's an animation. So for your low, all moving counterclockwise, clouds are spinning, air is moving in, rising, you're getting those stormy conditions. Further to the west, you have that high pressure, clear skies. Further down off of Florida, again, high pressure, clear skies. I've added on here now the cloud cover. You can see that shape, and we'll see that on satellite imagery as well, that you have clouds north of the warm front. Within the warm sector, it's pretty spotty. So if you know that you're going to be south of the warm front, you're going to have at least partly cloudy skies. It may end up being mostly cloudy, so not ideal conditions for viewing. But look how sharp this drops off. So on the back side of that cold front, clouds are going to clear out really pretty quickly. There's a little bit of movement right around that low still with some cloudier skies, but at least that's some good news when you're knowing that cold front is going to be passing. And then I'm going to add onto here some of the precipitation as well. And you'll notice it's a little bit more narrow compared to that cloud cover. So that rain really occurring along that cold front, rain a little bit spottier on the north side of the warm front and a little bit closer to that low as well. So kind of putting that all together and talking about generalizations, we know we have that warmer air. Warmer air is going to have that more moisture, and warmer air is also having lower pressure. So that's going to cause that instability, that rising air, clouds, lower transparency because of that moisture. So air rises, cools, condenses, clouds form, you get that precipitation. Whether you have precipitation or not, because of that greater moisture, it's still going to be lower transparency. Colder air, less moisture, high pressure, it's sinking, it's stable, you get those clear skies. So air sinks, it warms as it's sinking, it evaporates any residual moisture, so no clouds, dry conditions, better for your viewing. So anytime, if you're just looking at lows and highs, not even looking at frontal systems, a high pressure is going to give you better conditions for viewing and better transparency. So now let's talk about all the different steps for a frontal passage. We'll deal with this warm front first as it's lifting up across the area. So as the warm front approaches, you're going to get an increase in clouds and rain. So not a good time to view. Once that warm front passes, sometimes there can be a break in clouds, but you're going to be in that warm sector. So there is going to be that higher humidity. So even if you end up with a clear sky, you'll need to account for the fact that there's more humidity now in the air. As that cold front then nears from the west, wind is going to be increasing from the south. That's when you get storms. You certainly don't want to be outside and not looking at it. Cold front passes, clouds will be clearing, but here's the caveat and problem. It'll still be windy. Okay, so now we're going to kind of bring in that seeing element. You get a drop in dew points after that cold front passes. There's less moisture, colder air. It's going to be sinking. It's more dense, improved transparency. Yes, that's all good. But the wind will still be strong. So you're still going to have a turbulent atmosphere. So seeing will be low right after that cold front passes. The cold front's going to pass, you know, in the afternoon, in the evening time, and then you plan to view that night because the clouds are clearing out. You may still have some seeing issues because of the wind and turbulence that's there. So you really want that high pressure to build in the next day. There is that lag, but once that high builds in, you're going to have better conditions for viewing. And that means clear nights. So you want, obviously, no clouds, you want less moisture, but also calm nights. There's not any wind. That's going to be the best combination of having both seeing and transparency with you across the area. And I want to kind of add on to that. This was really focused on those frontal systems, which very much come into play for our weather fall, winter, and springtime. In summertime, it's a little bit more about our daily heating. So I wanted to go over this diurnal pattern that we have, so our daily pattern. As the sun comes down, it heats up the surface. You get that warm air right at the surface. It begins to rise. You get convective currents within the atmosphere with that. So you get mixing, what we call the boundary layer of the atmosphere during the daytime. Shortly after sunset, that mixed layer, that movement, it's still there. So you still have that turbulence present. So you're seeing it's going to be a little bit rough, especially during the summertime, the first couple of hours after sunset. Then it's going to become more stable as the night progresses. So that's going to be good for your seeing. As the night continues onward, and especially on those clear nights with no wind, so those clear calm conditions when you're probably going to want to be outside and looking, radiational cooling from the Earth's surface increases. So it's going to be really efficient that the heat that's at the Earth's surface is going to send out long wave radiation out to space. And so as that goes out, it'll be very efficient, and the surface layer of air becomes cooler than the air that's right above it. So you end up getting what we call a temperature inversion. So warmer air is on top of cold air. Remember, warm air rises. Well, if your cold air is already on the bottom, the warmer air doesn't have to rise. This becomes a very stable situation, which you may think, hey, stable, that means there's not turbulence. I must have good seeing and transparency, because we also know it's a clear night with no wind. But that temperature inversion can be good or bad. So it kind of went over those good things. Let's talk about, though, how it can be bad. First of all, it can be bad because fog developing. Now, if you're going to be viewing around midnight, 11 p.m., oftentimes we don't have as much fog then because the temperatures haven't cooled enough. But if you're going to be viewing after about 2 a.m., 3 a.m., it becomes more problematic for having that potential for fog. So it's something that you're going to want to look at when you're planning ahead. You're going to do some late night viewing if a planet is only available to be seen for a certain period of time, say at 4 or 5 a.m., especially if it's going to be in the valleys, and our area is going to be the worst for that. So you're going to want to look at the forecasted low temperature and the dew point and see if they're going to meet or at least be close to each other, and that'll give you a better indication if fog will develop that night. So here's a little animation here, if I can get my mouse to come up. Oops, there we go. Of looking at daytime heating leaving the ground. This is our clear night with light winds. That cooling is going to be really efficient as we're setting up during the nighttime hours. Now, this is going through. What you end up with then is to have more moisture at that surface layer, especially if it just rained recently. You're going to have more moisture with the plant life. You're also going to get that cooler temperatures right at the surface. So the air nearest the surface is cooling quicker. So you get, number one, that temperature inversion, but number two, moisture, cooler air. That's when that fog forms. So that water vapor is going to condense out and you get fog. And obviously that's not going to be good for you for viewing. So even if you have a clear night, it looks like it'll be great transparency and seeing. If fog forms, that's not going to help you. For us geographically, that situation is more problematic for valley locations. So I know that sometimes y'all meet on some of the mountaintops. That can be a situation as you're making plans. If you're seeing there's a potential for fog, that'll be a time that you'll want to go ahead and do that. And with that, you're getting those temperature inversions. Well, temperature inversions can be problematic for a couple of different reasons. So our normal profile that we've been talking about, warmer at the surface, colder above, that warm air rises, condenses, you get clouds, that's the normal setup. For an inversion, you get that temperature increases in a small layer above cooler air. So the warm layer traps the air beneath it, preventing rising air. So you end up getting this kind of movement. So your temperature inversion, it's stable, but sometimes it can create a little bit of turbulence that might be an issue. Overall, it's going to be a good thing. But remember, we can get some issues. We can get that fog that develops with it. And also this idea with the inversion. The longer that you have stable air, so stable air over time can cause problems. And you end up getting problems with lower transparency. So inversions can keep pollution from cities closer to the surface. And it's not just that nighttime temperature inversion that sets up, but repeated days with high pressure, because our high pressure gives us sinking air. That's going to keep pollution in place, especially in the summertime, and you end up getting that haze. So again, if you're on day 3 or 4 with a high pressure, you're like, oh man, we still have clear skies tonight, I'm going to go out and look. You can begin to have lower transparency, even though it's a cloudless sky, because of what's stuck there in the air. And with the way that Chattanooga is in our geography, kind of stuck in the bowl of the valley, you're going to have more of that haze developing. And so that is a long-term problem with the stable air and the high pressure. I just wanted to kind of mention that geography and seeing component. I think y'all will know more about this. I know how it relates to weather, but I just wanted to throw it out there to say that depending on how you have your mountain set up, it can create more waves of wind and cause some seeing issues as well. So this kind of wraps up to tell you what is our generalized best case. So for transparency, we're looking at wanting cooler temperatures, less moisture, no pollutants, whether that's smoke or pollen or ozone or whatever it may be. Seeing calm wind at the surface. You also still want slower wind aloft as well. So we're looking at those higher elevation charts. Stable pressure conditions and no nearby fronts. So we want that high pressure to have settled in, no nearby fronts that are going to be really moving anything along. So your best case then is to have a cold front that passes. It ushers in that cooler, drier air behind it. Those clouds are going to clear out. Your seeing is going to be good. You're going to want to wait about one night, and then the wind will be more stable. A high pressure, sorry, I think that first one should have said transparency is going to be good. Wait about one night, and then the wind will be more stable. That high pressure will build in. So you're going to get both good transparency and seeing is the best case. The downside, that's what we just went over, the longer the high pressure is there and stays in place, the more dust, pollen, pollutants can get trapped, then your transparency will decrease. And that's especially true in the summertime, and it looks hazy. So with that in mind, I wanted to talk about the setup that we had a week ago on Thursday, Friday, and Saturday, because we had clear skies, right? So this is what the satellite imagery looked like from Thursday afternoon. Right here is where the cold front was. So it had already passed our area. It was out in the Atlantic. You can see that kind of sharp edge and rays along the cloud line. The low pressure is going to be up here, and you're getting a little bit of backside cloud activity. In most of our area, we had clear skies. We ended up being clear for Thursday night. Here's what the surface chart looks like. So there's the low up here. There's the cold front that I pointed out. This is for Thursday night. We have a high pressure building in, but it's not quite over our area, right? And when we look at the upper jet, so this is going higher up in the atmosphere. This is our 300 millibar chart. You're looking at the jet stream here. You're still getting this big dip and some pretty strong winds right over Tennessee, North Georgia, and then lifting up across the region. So yeah, cold front has already passed, but we still have some wind dynamics that we're looking at. So this was the forecast. I just pulled this from the National Weather Service for that night. It says tonight because I made this last Thursday. So mostly clear skies, but I highlighted here north wind 5 to 10 miles per hour. So Thursday night, just looking at that, you know your transparency is going to be good because it rained, dropped all that pollen out of the air. Cold front has already passed. Those dew points dropped dramatically. You got low moisture, so transparency is good. But even though there's no clouds in the sky, your seeing is still poor because there is some turbulence. That wind is still whipping in, coming in from the northwest to the north at 5 to 10 miles per hour. That's just at the surface. It's a lot more active above that in the atmosphere. Then let's look at Friday night. So waiting one night later. Here's that surface chart. Look at that high pressure, completely settled over our area. You're seeing no isobars even close to that, these black lines. So that means there's going to be very little wind. There's just not anything to really push and move that air here at the surface. And we look at the upper atmosphere, this is our upper air jet. That strongest wind is way over here in the Atlantic Ocean. There's a little bit of a dip, but you'll notice this trough is really already settled off of the coast of North Carolina. And here we are right here in Chattanooga, just barely highlighted in that green, indicating some wind aloft. We're basically going to be seeing that moving out in much quieter conditions. So let's look at what forecast was. Friday night, clear, low around 33, so it's cold, so you know it's going to be low moisture. Northeast wind around 5, becoming calm. So your wind is dying down. So Friday night for y'all, you went out looking, you should have had really good conditions for both transparency and seeing. Quiet conditions were there, both at the surface and aloft across the atmosphere, no clouds, great night to look. Let's look at Saturday night then. Saturday night, still clear on the forecast, but here's the difference. South wind around 5, becoming calm. Okay, well, that's not that strong, Allison. Why is that problematic? Well, anytime you begin to have some south wind, that means you're getting some additional moisture movement. Doesn't have to be a lot, but maybe just a little bit of extra water vapor moving in. So seeing good, transparency, good to average. It's not a whole lot of moisture coming in, just a slight increase. And in fact, when I made this last Thursday, and then I was working on Saturday, we really hardly had any moisture advection. There wasn't really that big of a deal. I'm sure if y'all viewed on Saturday night, you still had great viewing. But as you're making plans and looking at that forecast, probably Friday night would have been the night to highlight looking at that. And that's what this chart was. Rob told me about the app that some of y'all use for the clear sky chart. And that's what we're seeing on here. So remember, Thursday night, we knew we had good clear skies, that our transparency was good. That's why you're getting this blue color right here with good transparency, because you didn't have any clouds, dew points were really low, and we knocked all the springtime pollen out. But look at how the seeing is just that aqua blue. So why do we have that low seeing? Remember, it was still because we had that wind. We still had turbulence in the atmosphere on the backside of that cold front before the high pressure settled in. But then look one night later, 24 hours later on Friday, that high settled in. We're now seeing that mid to darker tone blue on the seeing because we have a stable atmosphere in place. We have that high pressure. We don't have a lot of movement. It's clear, calm conditions, dry, low humidity. So you have good viewing all around. Going into Saturday, most of the night Saturday, really good. Let's bump back up to the transparency row. You can see early on Saturday morning, a little bit of that lighter blue. That's because we had that southerly flow, a little bit of a tick up in the moisture. That's why this clear sky chart is giving you a forecast of slightly lower transparency. And you can see that down here when you look at the humidity row as well with that red color. So again, if you're going to be looking at the weather, whether you're just going to look at this clear sky chart, they match up with each other and make sense as you're looking at that difference for what pressure is in place. Is it the high pressure? Do we have that low humidity? Do we have a clear sky with no clouds? What is the wind condition that we're looking at? So I wanted to go through and show y'all a few different resources that you can look at. Let me just escape out of this and I'm going to click back over to here and just see, do y'all want to ask me any questions now, or can I show you this data that y'all can look at? Okay, all right, so I can send the links to all of these to Matt or Ralph, and he can then send them out to y'all so you know about them. This is through the College of DuPage, and they have some really great resources. And this is probably the best, I think, tool for viewing satellite imagery. I don't know if y'all are aware of this or not, but you can choose different sectors. You can do goes east or goes west, whichever one you prefer. Goes east is going to be right over our area, so it's a little bit better. Right now, I have this set on the upper level water vapor. And so upper level water vapor is going to be really good to see what the movement is across the area of where there is a jet stream, where is there any kind of circulation or upper air troughs setting up. And you can see the circulation right here over Iowa and Illinois. So that's going to be an upper trough. Here is the area of that front that just came through our region this morning, bringing all of that rainfall. So when you're looking at that water vapor, you're going to know the setup across the atmosphere, and you're also going to want to look for On the upper air, darker blues, but look as we go to mid-levels and lower levels. Anytime you're getting these golds, oranger colors, that's going to indicate that the air is drier, so there's less moisture, so that's going to be good for you. If you come down and click the one that's called True Color, this will go through and transition between night and day to show you what that cloud imagery looks like. During the daytime, the one that's called Natural Color, I think it's really great that you can kind of zoom in on, and you can play around with different sectors. So I use the sub-regional ones a lot because it gives you a little bit more definition for our area, but at the same time, it gives you a bigger picture to see what clouds are moving in. And for y'all, this one is called NT Microphysics. Nighttime Microphysics is going to be huge. It's fantastic at nighttime for picking out cloud cover, and it will show you not just your upper and mid-level clouds, but does a great job for dense low-level clouds and fog developing. So if we have one of those clear, calm nights, and you can click on the nighttime microphysics if you're up at like 4 a.m. thinking you're going to go out and look at something right along the river, you can see where fog is forming right along those river valleys. So definitely check out the nighttime microphysics on here, and you can use that. So this is all real-time satellite imagery. Then if you just want to know what your conditions are at the Chattanooga airport, you can click on different airports going through. Obviously, you can look at your temperatures, your dew points, there's your relative humidity, there's your wind speeds. Like today, this afternoon, after that front passed, we still had a lot of really gusty wind. This side, which is called our Storm Prediction Center, they're going to be the ones that show you those different maps that you can look at. They're only updated twice a day based off of weather balloons that are launched up into the atmosphere. So it is going to be real data. If you click on the 250 millibars, this is going to show you what your jets are looking like. So we don't have a really strong jet stream right now, but you can see that circulation right there over Iowa that we saw in the satellite imagery. So that's always really cool to see that matching up. And then you can see that here's that 500 millibar chart that I showed you earlier. And then you can look and you can go down to 925 or the surface. And this will, with practice, I think you'll have a better idea of how to kind of read those. This is through the National Weather Service Weather Prediction Center. This is going to be your surface analysis map. So again, there's that circulation in Iowa. We had that first front that came through earlier today, and there's another front that's still off to the west of us. If you come over here to fronts, this is going to be really handy as you're making your plans maybe a week out at a time. So you can go through, and all of these are in Zulu time. So right now with us being on daylight saving time, 0Z is 8 p.m. So we're 4 hours earlier. 6Z is going to be 2 a.m. So you can go through here and see how those fronts are moving. And so you're going to notice really not good viewing across our area for the next couple of days. It won't be until, all right, this is Sunday morning at 8 a.m. Hey, finally, that last cold front has passed us. We see a high pressure getting kind of near to the area. Then we slide into Monday. It's really close to us. So you should have better viewing Sunday night and Monday night, especially Monday night moving through. Now, on Tuesday, we're looking at another front kind of passing. And so this is going to be handy stuff as you're learning about fronts and seeing on here where you can kind of plan out for the next week, which nights might be better for viewing. You, of course, can just go to the National Weather Service. This is through the Morristown office. You can just type in whatever city that you're looking at, whether it's in Chattanooga or Hickson, or if you're going to Cloudland Canyon. Here's going to be a forecast that you can look at. But one thing that I wanted to point out, if you scroll down and you click here on hourly forecast, this will go through the next 5 days. I think it shows up in the hourly forecast of what the temperature is, what the dew point is, where your wind direction is for each hour. And then this percentage in the blue, that's going to be your sky cover. So you're still going to be dealing with partly cloudy skies to mostly cloudy skies. If we jump forward a couple more days, this is Sunday. Let's look at this. Sunday, by Sunday morning, that's really clearing out. Sunday night, We're having much nicer sky cover, hardly anything, into the day on Monday, sunny skies. So that'll be handy. If you don't want to look at the charts with the line graphs, or if you want numbers for each hour, all you have to do is just do a regular click on it, and it'll change and give you all the individual digits, and it'll give you sky cover based off of percentage on here, which is handy. If you want to get deeper into looking at specific weather models, this is back through the College of Do page, and this is all free that you can view. Short term, the HER is going to be a really great model for you to look at. So you just click on the tab, you come to the sector that you want to look at. So I'm clicking on the southeast. You'll click on average cloud cover, and you can go through and see what that cloud forecast is. The HER is updated every hour. The ones that are updated hourly just go out for 18 hours, but then when you get your every 6 hours, the 0Z, 6Z, 12Z, and 18Z, they're going to run out for 36 hours, and they're developing it to run out for 48 hours. So you can get a really good idea of what the cloud cover is going to look like across the area. And remember, we're not just worried about clouds. You can also look at service products, see what that dew point is. Is it going to be rising? Will it be falling? You can look at wind as well. For long term, the one that's labeled GFS, that's going to be your long-term solution. So again, click on the sector that you want to do. You can look at precipitation, but of course you got the cloud cover here. It's going to do the same thing, that you can track those clouds. So you're looking here and seeing what those conditions are. You can look at your dew point. You can look at the temperature that's on here, the relative humidity. You can go up in the atmosphere if you want to and track conditions. If you want to see what the wind speed is going to be like at the jet stream, which is 250 millibars, you'll see that it's still going to be gusting pretty strong Saturday night across our area. We'll have another group of gusting kind of Monday morning across the region. So this will give you that bigger picture, and you can change your sector view to here over on the left. If you want to go back to like the continental US, you can look at all of that. So this is a great site. If you, the more that you kind of maybe want to play around with some of the weather elements, that this will give you a lot of different options to look at and see for forecasting. This here is through NOAA, and this comes more into play about the potential of smoke. So this is going to be your smoke forecast, the red, and you can, when I send you the link out, it's not going to have everything clicked, but you'll want to just click on near surface smoke, and you can click and select and highlight fire detection. So all the red dots are going to be where there's fires, and you can track the movement of smoke by just sliding this through. Oh, it's reloading right now. But it'll slide through if you want to see where smoke is moving, if there's any kind of wildfires nearby, because obviously that's going to affect what you can see. And then lastly, this site here is the National Weather Service's Weather and Hazards Data Viewer. So it's going to give you all of the places that have surface observations, and it's real time. You can also, you just have to check where it says surface observations. You can change different layers on here. You can add on radar if you want to. I have it selected with weather hazards and warnings. They're going to be highlighted, whether it's a tornado warning, a severe storm watch. You can also warning, whatever it may be. The further you zoom in, the more sites are going to be popping up. So even as you get closer to our local area, you're going to have your main airports that you can look at, but they're also going to be smaller sites that will also have weather data that you can select from if you want to see what the temperature, the wind, or the dew point is in a particular area. All you have to do is just come to that little round spot right there and click on it. More of it's going to pop up. And if you, well, of course now it's not doing it while I have you on here, but it should, whenever you click on it, to bring up when all of the data from that airport. So it'll look like this that I showed you to begin with. So hopefully that gets y'all very much started on what, guess I'll just stop that screen share. There we go. Of what to look for then, and resources that you can use for forecasting too as you go out in time. So the satellite imagery is going to be great for night of. And if you want to forecast a week ahead of time, go to that College UPage website, look at the GFS model, see what it's looking like for that cloud cover, go to the Weather Prediction Center and check out that surface analysis. And that'll give you a good idea about if a high pressure or a cold front is going to be settling in place over the area. All right. So I guess, does anybody have any questions now?
No, you're good. I just turned on our camera. I would like to say, and I put this in the chat, that was fantastic. And what a wealth of information to help the club with viewing and planning nights. I'm a weather fan. I wanted to, chase tornadoes when I was little. So this was incredibly interesting for me. And what a great resource. Thank you.
Of course. Well, thank you all for having me. Like I said, I'll shoot all of those links either to Matt or Ralph, and I'm sure that they can send them out to everybody. So that way you can just click on it and go to one of those websites and start exploring yourself.
Before we had the supercomputers, we had so-called Bermuda highs that used to affect our weather in the summertime. I haven't heard too much about that anymore.
Well, Bermuda highs are off of the Atlantic coast. So our Bermuda high is really over Bermuda. That's hence its name. So for the summertime, it definitely can work as a little bit more of a steering current. So as we get those tropical waves off of Africa or any developments there in the Atlantic Ocean, depending on where the Bermuda high is placed and how strong it is, and if it's bulging all the way over to the East Coast, that often is going to work to steer whether it is a full-on hurricane or maybe it's just a tropical low or depression. It'll work to determine, is it going to be going right up along the Atlantic coast? Is it going to cross over Florida into the Gulf Coast? Is it going to swing up into our area locally? So the Bermuda high is going to come into effect with those tropical conditions and steering it of where it's going to go, kind of that east-west, and when it'll make that north turn.
Alison, this is Ralph. I really appreciate this. You've done a fantastic job.
Oh, of course. Well, thank you all so much